Hey everyone, this is my Charges and Electric Fields Simulator term project. So my idea for this project just came from the idea that programming is taking the real world and translating it into something that a computer can understand. So in order to showcase what I've learned through this course, I really wanted to create something that simulated the real world. And I figured there was nothing more real world than physics, so I decided to create this simulation for charges and electric fields. So if we go to instructions, it just explains how the program works and all the different modes and how to access them. Then I go to start. You can see that the program is blinking. That's just because my computer is having trouble screen recording and running Python. But yeah, moving on to the program, you can see that this is the layout, and there's not much yet because there's a lot of empty space. But once I create and move these particles, now you can see that an electric field is being created. Um, and you can see the direction and magnitude of these fields using these sensors. So these sensors detect the magnitude of the field and the angle at any point throughout the field. And these are real values, as in if the distance between two arrows was a meter and the charges were 1 nanocoulomb, this is the real value of what the electric field would be. So that way the user is working with real values, and that's for every calculation throughout the program. So I can add as many particles as I'd like, and it would draw the appropriate electric field. And then I can get rid of particles like this and sensors. And then now I can move on to the different modes I have. So the first one would be path mode, where I can just put in a bunch of particles, press P, and now I'm in path mode, as you can see. So I press on a particle, I draw a little path for it, and then I can do that with all of them. Um, and then once I press on any key on the keyboard, you can see that it follows that path, and the electric field is being updated accordingly. So the user can play around with that and see how the electric field changes when multiple particles move. Now, getting out of path mode and moving on to, let's say, motion mode, I can do that by taking opposite charges, putting them on the field, and then once I press motion mode, you can see that they're attracted towards each other. So motion mode is really just having the particles interact with each other the way they normally would. That's being simulated by calculating forces, velocity, acceleration, potential energy, and kinetic energy. And so with that, you can see that they're slow at first because the distance between them is large. But then as they get closer and closer, they get faster and faster because the force is increasing, so the acceleration is increasing. So it's a very realistic simulation as compared to just like charges uh, repelling and opposite charges just attracting at at a constant velocity. So if I were to create this triangle right here, they start off fast and then they slowly go away from each other just because the force on them is decreasing as they're getting farther away. And so I also wanted to mention that I have a voltmeter here, which will detect a real voltage at any point in the field. And so if I can also create equipotential lines using this voltmeter. So if I just press on E right here when I'm next to this, then you can see an, an equipotential line being created. And so if I go here, I can also see another equipotential line being created. And so it wasn't as simple as just drawing a circle around the particle, just because if I have two particles interacting with one another and I create an equipotential line here, you can see that the equipotential lines interact with one another just because the particles are interacting with one another. I can go on to my next mode, function mode. So this is just for the user to be able to input vector fields and see the field being created. So that's what these boxes are. So I can change the coefficient of x, and you can see that it's being changed appropriately. And I can make it 0 and 1. So you can see that these are my axes and these are my vectors, and so the user can get an understanding of how vector fields work. Right, for example, with 0, all of the arrows, besides the axes, all of the arrows are pointing upwards just because the only thing we're dealing with is y, but then I can change that. Um, and so that's so that the user can get an idea of how to work with vector fields. And overall, the point of the program is so that users can really play around with and get a firm understanding of charges and electric fields and how particles and charges can interact with one another. And yeah, those are the features of this program.